Okay, so we started Unit 6 today. So this is day 1 of Unit 6. So we started with this warm-up. So pause the video, take a moment and try it. So we know how to simplify. This is called a rational expression, so it looks like a fraction with variables. And to simplify that, you should have already learned in previous courses a little bit about simplifying rationals. So what we know to do is to cross off any common factors. So I can see that x minus 2 is a common factor. So when I factor out x minus 2, I'm left with 1. And same thing with the x's, x over x squared. Remember way back when you first learned about exponents, x squared means x times x, so you would write it out, and then the x's cross off. They're excuse me, common factors, so then we're left with an x in the denominator. So that becomes 1 over x. The other way that you eventually were taught how to simplify exponents, x to the first over x squared, you learned that you subtract 1 minus 2 and get negative 1, and you can't leave negative exponents, so x to the negative 1 is the same thing as 1 over x. So that's why we have an x in the denominator there and a 1 in the numerator. Lastly, 2/6 we know simplifies to 1/3. So after I simplify everything that I can, I'm left with just a 1 in the numerator and a 3x in the denominator, and that's my answer. Now, after we went over the warm-up, and most students had that as an answer, 1 over 3x, we then talked about, or I taught how to find what are called domain restrictions. Some students had learned about them previously in other classes, others had not. So basically what a domain restriction is it's a value or sometimes values that cause the denominator to equal 0. And remember, you can't divide by 0. You learned that before. So when we have 0 in the denominator of a fraction, we know that means we're dividing by 0, which means that that's undefined. So what you have to do to get the domain restrictions is go back to the original expression and take the denominator, which is 6x squared times x minus 2, and set that not equal to 0, and then solve. Well, that works just like the zero product property works, even though it's a not equal rather than an equal. We still set both factors not equal to 0 and solve, just like the zero product property does. So on this one here on the left, if I divide both sides by 6, I'm getting x squared is not equal to 0. Well, I can take the square root of each side and get that absolute value of x is not equal to 0. But that doesn't make my answer plus or minus because 0 doesn't have a sign. So just x cannot equal 0. Here, x minus 2 cannot equal 0. I can solve that, add 2, and get x cannot equal 2. So in addition to writing 1 over 3x as my answer, I'm going to put a comma, and then I'm going to say that x cannot equal 0, and x can also not equal 2. And that is my final solution. Okay, so today's lesson, really just a few examples, simplifying rational expressions. And so I have students copy that one into their notes. And my question was, how is this one different than the warm-up? And eventually we realized that these expressions are not factored. And in the warm-up, I gave that to you already in factored form. So what you cannot do, don't do crazy things like, oh, x squared, cross that off. You cannot do that because these are minus signs. So we don't have common factors. Same thing with the x's. I can't cross off because that's not a common factor. Same thing with the y's. So what I need to do instead is factor it so that I can see if there are any common factors. So we need to factor the numerator and the denominator both. And remember, first step of factoring is always check for GCF. So in the denominator, I see there is a GCF, x times x minus 2y. Numerator, take a moment, think about that. What does that factor into? Should be relatively easy. We did a ton of these this year because factoring is very important. I've been stressing that all year. So we know that factors into x, and factors of 6y that are going to add to negative 5xy are going to be minus 2y and minus 3y. So now that I have factored, Now step 2 is going to be to get those domain restrictions like we talked about in the warm-up. So I take my denominator and I set it not equal to 0. So that means x is not equal to 0 from that first x, and x minus 2y is not equal to 0. Now this one's a little bit different because there's two variables. When you're solving for that domain restriction, you only have to solve for one of them. So I don't have to solve for both x and y, I can just solve for x. So if I add 2y to both sides, x is not equal to 2y. Okay, so those are my domain restrictions. And again, you don't have to say y is not equal to 1/2 x. That's the same thing as saying x is not equal to 2y. So I'm going to come back here, I'm going to simplify what I can, and then I'll include those domain restrictions in my final answer. So I'm seeing x minus 2y, that's a common factor, and that's it. Remember, you can't say x and x because that's being subtracted, and it's not a common factor. So my answer is x minus 3y over x, which I can include the parentheses or not, but I do need the restrictions x cannot equal 0 and also 2y. Okay. Next. So copy that one into your notes. So once again, step 1 is to factor if you can. This doesn't look like there's anything that factors. So I'm going to go right to the domain restrictions. Remember, setting, in this case, we have two fractions or two rational expressions, so we're going to set both denominators not equal to 0. So if I set 4y squared not equal to 0, or divide both sides by 4, I'm getting y squared is not equal to 0. Square root of each side, I'm getting y is not equal to 0. Same thing with the 5x squared. Divide both sides by 5, x squared is not equal to 0. Square root of each side, x is not equal to 0. So now I'm ready to simplify. And when we have two fractions or two rational expressions, you have a choice. You can either multiply the numerator straight across and the denominator straight across and then simplify, or you can simplify first, simplify the fractions themselves or the diagonals or both, and then multiply what you have left straight across. One of those is preferable than the other. Then the preferred method is simplify first and then multiply. And the reason for that is when you simplify first, you're dealing with smaller numbers and you're dealing with smaller exponents. But if you multiply first, then the numbers are getting bigger and the exponents are getting bigger. And then you have to try and simplify bigger numbers. Whereas if you simplify first, the numbers are nice and small, and then multiply, you're multiplying small numbers. So it's always preferred to simplify before you multiply. So I'm going to look at this first fraction, 3x over 4y squared. 3/4 doesn't simplify, x over y squared doesn't. Second fraction, I don't see anything that simplifies. But if I look on the diagonals, I do see some common factors that I can factor out. So this first diagonal here, 3x and 5x squared, 3 and 5 do not simplify. However, x over x squared, we did that in the warm-up, that does simplify. So the x over x squared becomes 1 over x. Looking at the other diagonal, I see a couple common factors. First of all, 2 over 4. 2/4 we know simplifies to 1/2. Secondly, y to the 4th over y squared. We know that simplifies to y squared over 1. So now I have simplified everything that I can, and I'm ready to multiply straight across. So I have 3 times 1 times 1 times y squared, which is 3y squared. Over top of 2 times 1 times 5 times x is 10x. You should always double check, make sure you didn't miss any common factors. No, nothing else factors there. So I'm ready to include my domain restrictions. X and y both cannot equal 0. And that is my final answer. Okay, let's try this next one here. So there's example 3. Again, copy it into your notes. So step 1 is the same as the last two problems. Factor if you can first. And when you factor, make sure you factor completely. So a couple of these expressions can be, GCF can be pulled out. And then they can be factored a little bit further. So take a moment, factor each one of those. So this I can factor a GCF of x out. I'm left with 3x squared minus 2x minus 1. And here I can pull out an x squared, and I'm left with x minus 1. I'll see if that trinomial factors further in just a moment. So I'm going to go ahead and keep that x squared over x squared times the quantity x minus 1 in the denominator. And I'm going to keep that x that I just pulled out, and now I'm going to try to factor that trinomial 3x squared minus 2x minus 1. So I know it's going to involve a 3x and an x and a 1 and a 1. And now I need to figure out multiplies to -1 and adds to -2. So I know that the 3x needs to be negative and the 1 needs to be positive. -3x plus 1x is -2x. Looks like they have the correct combination. Next, I can see this as difference of squares. You should very quickly be able to factor that. And lastly, there's no GCF on that one, so it's just a trinomial, which goes into two binomials. So again, 3x and x, factors of, looks like 9, 3 times 3, factors of 9 that add to 10. Well, that's 9 and 1. So that's my 9x, and that's my 1x, and they should be positive. So 3x plus 1 and x plus 3. Looks like that's correct. So now I'm ready to, once I factor, do step 2, which is the domain restrictions. So x cannot equal, from this x squared, cannot equal 0. From x minus 1, x cannot equal 1. From the x plus 3, x cannot equal -3. Those you can all do pretty quickly in your head, hopefully. The 3x plus 1, I'll show that one. So 3x plus 1 cannot equal 0, which means, subtract 1, 3x cannot equal -1, which means x cannot equal -1/3. So we'll include all those as our domain restrictions. Now we're ready to look on the numerator and denominator and see if there's any common factors for each rational expression, looking on each of the diagonals to see if there are any common factors. So I see x minus 1 over x minus 1. I see x over x squared again, so remember that's 1 over x. And now here at the other rational expression, I see x plus 3 over x plus 3. And looks like that's it for each of the separate fractions. Now let me look on the diagonals. I see 3x plus 1 and 3x plus 1. And looks like that's it. So now I'm ready to multiply straight across. 1 times 1 times 1 times 1 times x minus 3 is x minus 3. X times 1 times 1 times 1 is x. Now keep in mind, once again, you cannot cross off those x's because this is minus. This is not a common factor. It's not being multiplied. So I cannot cross off the x's. So that's my answer. I'm going to include my domain restrictions. So we said x cannot equal 0, 1, -1/3, or -3. So that is my final answer. Okay, next. This is our last example for the day. So once again, go ahead and copy that. So once again, you're going to factor everything you can. Looks like 3 of those expressions factor. So I'm going to go ahead. I see right away difference of squares. Hopefully you see that quickly as well. Numerator, take a moment and think about that. So we can see multiplies to -15, adds to +2. So I think 5 and 3. And we know that the 2 is positive when the terms are added. So that means the 5 is positive and the 3 is negative. So 5a minus 3a is 2a. Yep, that looks good. Here, GCF 3 times the quantity a minus 4. So now I have everything factored. I'm going to go ahead and figure out my domain restrictions. So in this denominator, a cannot equal either positive or -4, because I set either of those factors equal to 0 and solve, or not equal to 0. Here I have to look at this denominator as well. I'm getting a cannot equal 4 again, so I already have that. And now I'm ready to do the next step. Well, this problem says divide. So you learned previously when you worked with rational expressions, you know that dividing by a fraction is the same thing as multiplying by its reciprocal. Meaning I'm going to keep this first rational expression the same. But I'm going to change the division to a multiplication, and I'm going to get the reciprocal of that second fraction or rational expression. And now you have to think about that. Now that we have gotten the reciprocal, now we have a denominator that we didn't have originally. So think about what that affects. If I have a different denominator, now there's another opportunity for us to have 0 in the denominator, which means we have to include that in our domain restrictions as well. So you have to include anything that causes domain restrictions from the original problem. But when it's a division problem, you also care about the denominator of the simplified problem after you've changed to multiplying by the reciprocal. So I need to include a also cannot equal -1 from setting a plus 1 not equal to 0 and solving. So keep that in mind. You probably want to jot that in your notes, that when it's a division problem, you get the original domain restrictions from the original denominators, but also you get the domain restriction from the new denominator after you've gotten the reciprocal of the second rational expression. So now we're ready to simplify. So I'm looking on diagonals, and I see a minus 4s. And looking on the other diagonal, I don't see anything. Looking on top of each other, I don't see anything. So now we're ready to multiply straight across. When you have more than one binomial, you do not have to multiply it out. It's fine for you to leave your answer in factored form. So I'm just going to leave, I'm going to put the 3 in the front, and I'm going to leave the two binomials in factored form, not multiplied out. And in the denominator, a plus 4 and a plus 1. Now, you have to be sure to put them in parentheses because we're showing that that's factored form. You don't want to leave the a plus 1 without the parentheses. Now it needs it because I'm multiplying. But I don't have to actually multiply it out. So that's my answer, comma, and then I'll include those domain restrictions. A cannot equal plus minus 4, plus or minus 4, and -1. Okay. And that's it for your lesson for today. So tonight for homework, you're going to do page 1 in the new packet, and you're going to complete worksheet number 6 in Unit 6. Remember, we just started the new unit, Unit 6, worksheet number 6 for tomorrow.